All right, so we're going to solve trig equations, which is the same thing as finding angles. Now, the trig equations we talk about here are not necessarily going to be real complex. It's more of the theory behind what does it mean to say that the tangent of x equals 1.5 from 0 is less than x is less than 2 pi. Okay, now what it means is we're trying to find x, and I would almost expect, and it's not wrong, that your knee-jerk reaction should be to do the inverse, okay? Because if I do the inverse tangent, I end up with x, I end up with this 0.98. Listen, that's in radians, so 0.98 is referring to a radian angle, okay? And by the way, it is right, but it's not the only right answer. It's not the only right answer because there's actually another x that's inside of this domain. So I actually wanted to do this problem a little bit more from a graphing perspective, where we take each side of the equation and graph it. Now, if you look at what I did here, I'm going to graph tangent, and I'm going to graph 1.5. I'm going to graph each side of the equation. Don't forget that you want to be in radians, and you should probably hit zoom trig just to kind of reset that window. So we get the crazy tangent graph, but if you can kind of see between all the lines here, what we're really looking for would be the intersection point or intersection points. And so both these purple dots are actually between 0 and 2 pi. Okay, now if you trace to the first purple dot, you see that it's really close to our first answer. It is. The first purple dot is supposed to be exactly 0.98. But it's that other one, it's the next one that we also want to find. Now, I wanted to remind you of a feature on the calculator, and it's not just tracing, because if I trace, I get close to the purple dot, so it's close to 4, but we should be able to do better. Second trace is the calc menu. Second trace is the calc menu. Go down to intersect, where we're going to find the intersection of the curves, where you hit enter for the first curve, the second curve, and then you make a guess. You basically hit enter 3 times, and we get the exact x value, 4.12. Okay, now for that problem, we used a graphing method. And the reason we used a graphing method is because we had awareness that tangent repeats itself. And if tangent repeats itself, then I can look on a graph for those places that are both going to equal 1.5. By the way, when you, in your assignment, if you use a graphing method, you want to draw the graph. You want to show what you did. Notice that I simply showed a sketch, and then I showed the intersection points, but the rest of it I did on my calculator and got those two values. Okay, let's take a look at an equation that is going to use some algebra to solve. We'll solve the next one with algebra. Graphing method for solving tangent equals 1.5. I want to show you an algebraic method for solving one of these equations. Okay, we're going to use like an algebraic method. Now here, the cosecant equals -4. And, you know, remember what I said, we're not like solving like a really complex trig equation. Whether you remember or not, you solved ones that, you know, use sine squared and cosine squared and all kinds of trigonometry. We're just trying to get to the theory of this. Now, this one, we're going to try to appeal to more of an algebra method, meaning we're not just going to push a couple buttons on our calculator. And it gets to a little theory. First piece of theory is that cosecant is really just a sine in disguise. Okay, in other words, the reciprocal of cosecant is sine. Now, before you say you can just do that, well, what I did was I did the reciprocal of the left side of the equation. So guess what I'm going to do the right side of the equation? The reciprocal. Okay, that's legal algebra. I did the reciprocal of both sides. Now, conveniently, that gives me a function that I feel a little more comfortable about, the sine function. It also allows me to start thinking about what the heck does this mean? Now, 1/4, negative 1/4, is not an angle. X is an angle. But negative 1/4 is a y over r. Remember looking at those definitions for a few minutes yesterday. What do we mean it's a y over an r? Well, it's a y and an r from a triangle. Before I go any further, I apologize. I forgot that I wanted to have this little domain restriction. Pretty common that normally we'll give an answer or answers between 0 and 2 pi. Okay. Now back to the regular scheduled program. We've got this y and r. And this is kind of the good stuff here. This is the good stuff of trigonometry. There's a triangle that has a negative y value. Do you see it? Do you see a triangle with a negative y value? It could be that one. Okay, because it's got a negative y value. It could also be this one because it's got a negative y value. Okay, by the way, the r value is always positive, so I can kind of fill that stuff in. Now, if this was trig class last year, you may have wanted to, and I guess I say that you still can, find the other side. You're going to find out that for the answer to this problem, though, it doesn't really matter. But sometimes kids will find the other side. That was just Pythagorean theorem, square root of 15. But it gives us an opportunity to remember that it's actually negative square root of 15 because, well, again, it's a negative dimension. Now, here's where we get a little bit deep into the theory, okay, because we're looking for an angle. We're looking for an angle. That angle is this angle, okay, because angles are always measured from the x-axis. So we're looking for that yellow angle. Or that angle is actually this angle. Okay, sometimes I find that students can draw the triangles, but you're not sure like where the answer is. The answer is an angle. And again, each of those rotations is what we seek. Okay, now, to find that angle, we need still to do something on our calculator. We need to basically still do the inverse. Okay, we need to do an inverse. Maybe you've heard it said that an inverse always gives an angle. Okay, so I'm talking about the inverse sine of negative 1/4. You know, it's okay to do it. Check it out. You don't get like 30 degrees. You're not going to get degrees anyway because you're not in degrees. Okay, but you get this 0.25 number. Now, 0.25, negative 0.25, is actually referring to this angle, this sort of rotation from the x-axis. Okay, because rotations are always given as principal values. That's kind of fancy talk for they're always given as the close one. They're always the close one. Now, what I want you to realize, and this is we're a little fancy in the weeds here, but I want you to realize that one of the answers is not negative 2.5, but we're going to use negative 2.5. Okay? It would just kind of be a little too basic. You're missing the idea if you just got your calculator out 5 minutes ago and said negative 2.5. But I kind of wonder if you guys are ready to kind of use it to get the yellow rotation, to get the pink rotation. Anything you bring to the table? Any thoughts? How about the size of the old angle over here? Okay, it's the same. So, you know, whether you want to say it's 0.25 or negative, maybe you're not sure if it's positive or negative, but the idea is, like Aaron said, it's the same. I'm having trouble squeezing it in here, but I'll squeeze it in. We're looking for the yellow angle. Pretty close, aren't we? How far is it to rotate to this checkpoint, to rotate basically to the negative x-axis? That's going to be pi. Okay, we got to talk radians now. Got to talk radians. So we rotated pi. You see where I'm going? I need to get the rest of the yellow. I need to get the rest of the 0.25. So one of my answers is going to be pi plus 0.25. Now I got to clean up my not equal to sign here because that's not really true. Now it's equal. Good.
So you want to add one degrees, right?
Okay, now, first of all, you could add those. You could take 3.14 plus 0.25. I would give you credit for that. Okay, but you don't need to convert to degrees. I know it might make you feel better, like, to get 200 degrees or whatever it is, but it's okay to write the answer in radians. It's actually the way you want to write the answer in radians. So it's actually okay to write the answer as pi plus 0.25, because a lot of times when pi is involved in an answer, we show it. It's all right, but understand it. It's an angle, okay? It doesn't have to be in degrees, though. How about the pink one? How about this hot pink one? M?
Would it be 2 pi minus
2 pi minus the 0.25. How'd you get that?
because go around is pi and then this is 0.5.
Yep. Now look. All these answers, it's actually just two answers, but all these answers are between 0 and 2 pi. Remember the first answer? Negative 0.25. Okay? We're glad we had it, but that's not between 0 and 2 pi. So we don't write that in the list, but we're glad we had it because we used it as a reference angle. That's a little term from last year. It's a reference angle. Listen, that's not easy, and you probably didn't even do that last year. Okay? I didn't teach a problem like that, but you're using skills from last year, kind of taking one more step, okay, to solve that. Now, if you're like, am I supposed to use a graph like you did on this one, or am I supposed to use algebra? Okay, I'm going to leave it up to you, okay, but you should, I'll say, understand both of them. Okay, so when you do your assignment, you should find one that you can do this way and one you can do this way. Okay, I want you to understand both methods. Solving a trig equation, maybe not quite what you thought, because you solved some much more complex, at least in terms of like the way the equation was written, but this is more the theory. Now what I'd like to do is something that kind of feels similar, but it's different. We're going to find some trig values. Now, finding trig values is not the same as solving an equation. And I think that the main thing that you want to take out of this is how it's different. And some of it is just because of the way that the problem is given, the way that the question is asked. If theta equals the inverse cosine of negative 3/5, find the sine of theta, cosine of theta, and the tangent of theta. As you write some of those things down, just notice that it's not the same goal as the last problem. We're not trying to solve for x. We're not trying to solve for theta. And sometimes that's where kids are like, so what am I trying to do? You're trying to find the sine of theta, the cosine, the tangent. Okay, now what that means is you're actually trying to find the good old y over r, the good old x over r, the good old y over x. You're trying to find those ratios. That's what it means to find a trig value. Okay. Oh, I think you can add this. Sorry, something I forgot here. This will be part of the given. Part of the given. The sine of theta is greater than 0. The sine of theta is greater than 0. Now, I'm not even going to do this, but we'll talk about it. That is, put that in your calculator. The reason I'm not going to do that is because it's not going to be helpful. If you put that in your calculator, you're just going to get the angle. And it's probably going to spit out to be some messy decimal because it's in radians. I'm trying to get you the idea that we're not looking for the angle. We're looking for the sine of the angle, the cosine. So what we actually need to do, kind of back to theory, is think about what this means. Okay, now, what this means is that the cosine of theta is equal to -3/5. I'll be honest, all I did there was just a little take the inverse and bring it back over to this side. Okay, now what I wrote for you here means the same thing, it's just not in inverse notation. But we still need to do something with it. We still need to interpret it. So you ready? -3/5 is your x and your r from a triangle. Okay, what triangle? What triangle? Well, there's some triangle that has a negative x value. You want to start to picture it because a negative x value could be from this triangle, okay, simply because it's in a negative x position. It could also be from this triangle, simply because it's in a negative x position. Now, hear me out. Those two triangles I just drew, or kind of pictured, are all based on the given. Simply that the cosine is negative, the x is negative. Okay, so we have this extra statement. We kind of have this additional statement that says the sine is greater than 0. That's just fancy talk. That's just fancy talk for positive y. Positive y. Because sine is y, and you know what greater than 0 means. Are you ready to erase one of these triangles? Now, putting the dimensions on this triangle, putting -3, putting 5, and I hope putting the missing leg here, okay, Pythagorean theorem, or 3, 4, 5, whatever you kind of jumps in your mind there. But in any case, we find that missing side to be 4. So the answer is the dimensions of this triangle, y over r, 4 over 5. -3/5. Now, that's kind of where we started, but okay, we still have that. And then, of course, 4 over -3. Look, I get it. We're trying to manage a lot of things. We're still just getting started. I still want this to be kind of interesting to you. And when we go through calculus, I definitely want it to be interesting. In other words, I'm going to help you understand the reason behind things. But we can still talk about the reason behind this, okay, even though it's more of a concept from last year, especially these two numbers, because I want them to be more than just two numbers. Okay, yes, it's the sine and cosine. But remember that this actually refers to, and this refers to, the ordered pair of this point. Now, this point right here isn't just any old point. It's the point on the beloved unit circle. Okay, so that point technically is this x and this y. In other words, -3/5, 4/5. And I guess what I'm just trying to drive home one more time, because I can, since you're a captive audience, is that that's what trigonometry is. Trigonometry is the fact that you have a unique point that matches with every angle. Every angle has a unique matching point. Okay, and that's really what these answers are. Here's one more little variation of the same kind of problem, finding the trig value. It's a variation because the given is a little different. We've got a point. So, okay, now, the problem is giving you a point. And we've got this thing about theta again. But we kind of have the same directions. We have the same thing that we're trying to find. Now, when I teach this to trig kids, and maybe your teacher did the same thing, we try to get students to realize that this information still goes back to a triangle. In other words, a sketch. And so if you plot the point, root 2, root 2, if you plot that point, if you draw the angle that goes with that point, okay, you start to get back to that same place. The place is a triangle. Now, understand that that triangle has to be right there because that's where the point was. The one I did over here had some negative numbers. But yeah, you can be sure that this triangle is in this place. You can be sure of the dimensions of the triangle. That is the legs. And then, of course, you can eventually get the hypotenuse. Whatever you got to do, I don't want to just say it. I want to make sure you understand that the Pythagorean theorem is kind of in the background here. So you can end up with your other dimension. You can get your other dimension. But then you're back to trig values. Trig values are the ratios of the triangle. Okay, the ratios of the triangle. Make sure you know those definitions. We're not going to sing a song about them, but I'm talking about all the X's and Y's and R's. If for some reason you didn't have to remember them from last year, it's something you want to study this year because there'll be a question on the test, and if you can't remember that sine is Y over R, then you kind of have, you're guessing which way to put it. Okay, so again, those same definitions. Okay, one more time. That's what that means. Okay, root 2 over 2. It's actually the value of that point, x comma y. And that's the only point that's ever going to match with that theta. All right, get a little nourishment. When you guys come back, there'll be a little present for you. It's one of these questions about a graph, okay? It'll be good for you, though. It'll help you to learn how to do what we were talking about yesterday.